Okay, 7th graders, this will be our second to last lesson in chapter 1. So we are on 1-9. I can solve simple addition and subtraction equations. And if you're following along with your book like you should normally try to do, we're on page 65 to start. Some things you'll see in this section and when you're talking about equations are different properties of equality. Hopefully we know that equality means equal and remaining equal. What the subtraction property of equality says is if you subtract the same number from each side of an equation, the two sides remain equal. So pretty much what they mean is if you do something to one side and you do that same thing to the other side, everything should remain equal as it does on both sides as well. Same thing on this other side. Even if both sides don't look equal right away, they're telling you that they are. A number, x plus 4 is equal to 6. So then we can find out what x is by subtracting the same, doing the opposite, getting rid of that 4, bringing down our x, subtracting 4 on this side as well, ending up with 2. And we know we can check our solution by doing 2 plus 4 equals 6. 2 plus 4 is 6, so that my solution was correct. Okay, so we'll talk about why subtract and in which situations, but we do need to know that whatever we do to one side, we need to do to the other side. So solving addition equation. Solving an addition equation, the reason you use subtraction when solving an addition equation is because subtraction is addition's opposite. They are each other's inverse operations. Operations, can't fit that on there, and they are each other opposites. So I always like to think of solving equations as kind of like what you do when you lose something. Say you lose your planner in 5th hour, and you remember that you had it in 3rd hour. To go and find out where it is you retrace your steps and you work backward. Okay? Since addition is adding something on, working backward is taking something away, subtraction. So kind of keep that in mind, inverse operation. Okay? So there are a couple different methods to solve. What we're trying to find is x. Trying to find out what number plus 5 equals 3. I'll show you a couple book examples. So method 1 would be to use the vertical method, which means that I'm going to use my inverse operation. I know that I'm adding 5, so I want to undo that by subtracting 5 right here, because, well, 5 minus 5 is 0, so the only thing that comes down is x. Whatever I do to one side, I have to do to the other side, so then I do 3 minus 5 is negative 2. And maybe you guys need to do that, add the opposite, so you know that you have more negatives than positives, 2 more. Another method would be the horizontal method. So maybe you, just like in the example above, this is easier for you to look at, that 5 minus 5 is 0 and it's gone. And this is easier for you to see 3 minus 5 is 3 plus a negative 5. And you still end up with the same solution as you did above. Okay? So kind of just deciding which way you like to work. For these simple one-step equations, that's okay to do the horizontal. It might get a little harder as the equations get larger and there's more work on them. This little study tip here is important. It's called isolating the variable. It might be hard to read. It's in your book. Isolating the variable is your goal of getting this variable by itself. We started with x plus 5, but we took 5 away so that we could have x alone on both sides. So isolating the variable, isolate means alone. Really important part is that you're going to be checking your solution. Checking your solution just means that you're going to plug in into the original. We found out that x equals negative 2, so what we did was we plugged x into where x belonged and then solved. So then we checked, okay, negative 2 plus 5, I have more positives than negatives. How many more? 3 more. When you end up with this reflexive property, that means it's true and that your solution that you had before was correct. Checking your solution is something you're going to get used to and you will do the rest of your time in math this year and on. Here are a couple for you to try involving the same thing, involving subtraction. So you could pause me now and give those a shot, and I will write them up as well, and you can check your answers with me. They're in your book on that same page. So I have a number plus 6 equals 2. Maybe I have a certain A stands for apples. Remember we defined our variables before? A stands for the number of apples I have. I add 6 more to them, and now I only have 2. I'm going to predict that A is going to be negative if I didn't go up further from 6. So I'm going to say, okay, I want to find out how many I had ahead of time. I like to make my train checks or my slide to keep things equal. So I take that 6 away to find out how many apples I had before I added on. So that goes away. 2 minus 6, more negatives than positives, 4 more. So I get A equals negative 4. I owed someone 4 before I even got 6. So I plug that into check, plug A in for A. So negative 4 plus 6 should be equal to 2. Negative 4 plus 6, more positives than negatives, 2 more. So since I ended with that reflexive, my solution is correct. Next one. Keeping everything equal, one side to the other. Y plus 3 equals negative 8. So what did y represent before I added that 3 on? So I'm going to undo and take that 3 away. And y is alone now. Y should have equaled, well, here we go. I'm going to add the opposite. Negative plus a negative is a negative. 8 plus 3 is 11. So I'm going to plug that back in a check before I make sure I think I'm right. So I have a negative 11 plus 3 is negative 8. Is that true? Well, more negatives than positives. How many more? 11 minus 3, negative 8. Since it's there and they match up, then my solution is correct. Hopefully you're off to a good start. If you did make a mistake, just make sure you're realizing what it is and you learn from there. Notice here are variables on this side. That's okay. We're still the same thing because we're working on the left and the right to do whatever is on the same. So a number n plus 4 gives me 5. Sure, maybe you know this in your head, but we still need to show our work so we know that we know the concept of inverse operations. Opposite of adding 4 is subtracting 4. 5 minus 4 is 1. N's alone over here. Check my solution. 5 equals 1 plus 4. 5 indeed equals 5. So n does equal 1. Notice how I write my variable first. Just like the opposite, adding and subtraction, we called this our inverse operations because they undo each other. For this reason, you can use the addition property of equality. Just like what we did. When we saw addition, we undid it by subtracting. We're going to do the same thing here. Okay, so just like before, we added on a number, we subtracted, now we're adding, and we end up with the same thing. We are subtracting 5, we're going to add 5 back on to get that to 0 to isolate the variable. It's alone. Same thing on the other side, like that. So if you add a number to each side, the two sides remain equal. Inverse operation. Here's another one, and we'll try some subtraction problems as well. Two angles are supplementary if the sum of their measures is 180 degrees. The two angles shown are supplementary right on the right here. So these are supplementary, meaning they should add up to 180. Write and solve an equation to find the measure of angle x. So we have our variable. We're looking for this. This is what we don't know. We're looking for that measure. So in our book, we see the sum of the measure is 180 degrees. Sum tells me that I'm adding to get something that's equal to 180. And we have a variable x to represent our unknown value. But we know the sum of the measure we do know y and the measure we don't know x should add up to equal 180. So you can write that equation just like you read it, like that 1-7 lesson will help, writing down what we read. And then you can solve it by, okay, well, if that angle plus the other one should give me the 180, that means 180 minus that 94 should give me the remaining angle I need. Okay, so just undoing what happened to get to an answer to find out what you need. A novel is ranked 7th on the bestseller list. This is a change of -8 from its position last week. Write and solve an equation to determine the novel's ranking last week. Well, a novel was ranked 7th on the bestseller list. The change of -8 from its position last week. Okay, write and solve an equation to determine the novel's ranking last week. Right here it says last week. That's the thing we don't know. So maybe I make W for week or L for last week. Define the variable. Last week's rank. Currently, it's ranked 7th. So right now we know the current rank is 7. But what happened, this is a change -8 from its position last week. So 7 is 8 less than last week's. So there's our equation because we just kind of rearranged things that we read. Now it wants us to solve. So the opposite of subtraction here would be adding on 8. So then we have 15 is equal to last week's rank. We can plug that in and check. 7 place rank is equal to last week's rank of 15 minus 8 positions from last week for this week's rank. And I'm going to check 7 is equal to 7. So last week's rank was at 15. So these are some subtraction ones that we need to get to too. So just doing that opposite of adding. So that inverse operation. Now I see, make my tracks. Something Y, maybe I have yams, and I have a certain number of yams and I get rid of 7. I'm going to give someone 7. Now I have -6. So I must have not had enough to give away. So I'm going to put those 7 back. -6 plus 7 is 1. So I maybe only started with 1 yam. I better plug it into check. -6 is equal to, over here, -6 is equal to 1 minus 7. 1 minus 7, add the opposite, is a -6. All right, notice position of the variables. Here, it does, if it bothers you, you could also begin solving equation, for example, 3, by rewriting the equation so the variable is on the other side. So just kind of rotate it around and not changing anything. So y minus 7 is equal to -6. You should be able to end up doing the same steps, but then it just ends up the right way forward, left to right. All right, try a couple of these and then come back in and check. Make my tracks, keep it equal. Since the opposite of subtraction is addition, I'm going to put the 8 that I took away back by adding. -8 plus 8 is 0. Do the same thing on the other side. So I have x is equal to -3 plus 8, more positives than negatives, 5 more. Check your answer. 5 minus 8 should be -3. The opposite, more negatives. So my solution works. Important part. Couple more. A number b minus 4, or 4 less than the number b, is -10. Well, let's put those 4 that we took away back to find out what b was originally. -10 plus 4, more negatives, 6 more. So let's see. If I have -6 and I take 4 away, I should end up with -10. Add the opposite. Notice that's important. If you're still struggling with integers, make sure you're asking. 2 negatives put together for -10. B was -6. One more over here. And remember, if you'd like, you can rearrange this, and I'll just do that right now. P minus 12 equals 7, for those of you that want your variable on the left. Undo taking away 12 by adding 12, inverse operation. Do the same on the other side for the properties of equality. So then P comes down, equals 19. Plug it in. 19 minus 12 should equal 7. What do you know? It really does. was kind of try to finish it up quick there so it wasn't too long at the end. Make sure you look over your book. Remember the important phrase of inverse operations and undoing what's been done. And rewatch the video if you need to, different parts. Book is a great resource. And check out those personal tutors. See you next time.